Hi everyone, I wanted to go through about 4 more examples for section 5.5, the greatest common factor and factoring by grouping. The first problem that we are going to go ahead and take a look at will be what we'll kind of describe as a basic problem. So what I would encourage you to do is to follow along. Once you see the full problem, I would pause the video, try it out on your own, and then hit play again so that you can compare your work with mine. So our first question that we have is 4a to the fourth b squared plus 6a cubed b squared plus 2a squared b. So the first thing that I would do is we're going to take a look at this in parts. And as was mentioned in class before, factoring is the reverse of multiplying with polynomials. So in other words, we're kind of trying to find we are trying to find the common factor, but as we're doing that, we want to look for a common value that will divide each of the terms. So the first thing that we'll look at will be the coefficients. So I'm going to look at 4, 6, and 2. And I want to decide what value or what factor is common between all three numbers. Well, in this case, 2 is the most common number. We can kind of, I guess, spread this out by saying, well, 4 is 2 times 2, 6 is 2 times 3, and then 2 is 2 times 1. They all have the 2 in common. So that's why I'm going to remove the 2. So the next one that we'll take a look at will be the a's. So we have a to the fourth, a cubed, and then a squared. So basically we want to find out how many a's does each of these terms have in common. And well, again, just to illustrate this, if we have a to the fourth, a cubed, and a squared, this is a times a times a times a, and this is a times a times a, and a times a. So as you can see in this situation, they all have 2 a's in common. So I'm going to remove an a squared. Lastly, we'll take a look at the b's. B squared, and b. And how many b's do all three terms have in common? And in this case, they just have 1. So then once we are done, we go ahead and we write what is left over. So at this point, we'll go a little bit slower, but just, I guess, follow along with what I have to say here. So 4 divided by 2 will give you 2. A to the fourth divided by a squared will give you a squared. B squared divided by b gives you b. And then we start the process over again. So 6 divided by 2 gives you 3. A cubed divided by a squared gives you a. B squared divided by b gives you b. Plus, now notice 2 divided by 2 gives you 1. A squared divided by a squared makes it go away entirely. B divided by b makes it go away entirely. So here is our final solution. And if you're not 100% convinced that that is correct, you can do a check by multiplying everything out. So 2 times 2 is 4. A squared times a squared is a to the fourth. B times b is b squared. And we can repeat this. So 2 times 3 is 6. A squared times a is a cubed. B times b is b squared. And then lastly, 2 times 1 is 2, and then the a squared and b. And notice that we do arrive back at the original problem. Okay? So let's take a look at another one. This one is going to be pretty basic, I would say. So if we go ahead and we take a look at the following, negative b to the fourth minus 3b squared plus 2. Notice that there really isn't any variable, there isn't any coefficient that is common among all three of these terms. But I do have this negative that's out in front that's going to kind of bug me. So it's kind of, I guess, best practices would be the way to say it, to remove a negative 1. So it's actually a fairly quick change. So if I remove a negative 1 from all of the terms, essentially what we are doing is we are changing the sign of each term. So if I remove a negative from negative b to the fourth, I'm just left with b to the fourth. If I remove a negative from negative 3b squared, now it's a positive 3b squared. If I remove a negative from a positive 2, then it's a negative 2. Again, if we check, and we were to multiply this through, negative 1 times b to the fourth would be negative b to the fourth. Negative 1 times 3b squared would be negative 3b squared. Negative 1 times negative 2 gives me positive 2. So again, you can check and notice that we do get back to the original problem here. Okay, so let's move forward to something a little bit more complex. Let's go ahead and do negative 8a squared b squared minus 12ab cubed. And again, what I would suggest doing is, well, the issue that I'm seeing here is that there is a negative out in front. So again, best practices would be to remove that negative entirely. So I'm going to set that negative on the outside. Now let's focus our attention on the coefficients. So 8 and 12. And the greatest common factor that I can think of between 8 and 12 would be 4. Okay, now we will move to a squared and a. Well, the highest number of a's that both terms have in common is one of the a's. And then if we look at b squared and b cubed, again, if we need to, you can always do this quick check for yourself. There are two b's that are in common, so b squared will come out. So then we need to ask ourselves, what is left over? Well, negative 8 divided by negative 4 gives us the positive 2. A squared divided by a leaves us with 1a. B squared divided by a b squared would leave us with no more b's. Oops, I jumped ahead, right? So negative 12 divided by negative 4 gives us a positive 3. A divided by a would remove all of our a's. B cubed divided by b squared leaves us with a b. So there is my final solution. And again, we can check. So negative 4 times 2 is negative 8. A times a is a squared. And then b squared would just go along for the ride. Negative 4 times positive 3 gives us negative 12. A pops in. B squared times b is b cubed. So again, we ended up with what we started off with. Okay. So last one that we will take a look at will be a factoring by grouping example. So let's start off with 3a cubed b plus 3a squared b minus 2a squared b squared minus 2ab squared. Okay, so first off, let's go ahead and take a look at all those coefficients. Let's see if there's anything in common that we can factor out or remove entirely. And in this case, it doesn't look like any of the coefficients we can remove. 3 and 2 are prime numbers, and therefore they wouldn't have anything in common with each other. So let's take a look at all the a's here. So it looks like I have an a cubed, I have an a squared, and an a. So that means that I can pull out an a from every one. Moving to the b's, b, b squared, and b squared. So I can at least remove one b from everything. So this leaves me with 3a squared plus 3a squared, or 3a. Let me remove that little dot so that we're not bugged by it later. Minus 2ab minus 2b. Okay, let me make sure that I've written all of that down correctly. And I am happy with what I have. Okay. So now, when you take a look at this polynomial with 4 terms, notice that there is nothing left that is common between all of them. And this is where the idea of factoring by grouping can come in. So basically what you're going to do is you're going to couple your terms in your polynomial. So in this case, I am just going to kind of be, I guess you could say, lazy and just group them the way that you see them, the way that they're written. So my first one I will go ahead and do in red. So for this one, note that there is a 3 in common and there is an a in common. So if I note here, both have a 3 in them, and then if one term has an a squared and the other one has an a, that must mean that they have one a in common. So I'm going to remove that. So we need to know what is left over. If I remove a 3 from the first term and an a from it as well, then I'm just left with an a. And then if I remove a 3 and an a from the second term, the only thing that I have left is a 1. For the second term, I'm going to go ahead and say, well, I see that I can remove a -2, and I can remove a b. So if I remove a -2 and a b from this first term, then I'm just left with a positive b. Oh, no, sorry, I am not left with just a positive b. I am left with an a. And then if I remove a -2b from the second term, then I'm just left with a positive 1. Okay, so at this stage of the game, we're almost done. Let's see here. The a and the b are just going to drop down. So right now we have this set up. So we have ab times the quantity of 3a times the quantity of a plus 1 minus 2b times the quantity of a plus 1. But notice that these are 2 separate terms because they are separated by the subtraction sign. Notice that each one has an a plus 1 in their terms, so we can factor that binomial out. So now we have ab times the quantity of a plus 1. I'm going to remove that. And then we're left with the 3a minus the 2b. This is where it's completely factored. Okay. So notice, as we run through this, that once you pulled that AB out, it just kind of kept dropping down. It really didn't do anything else as we were going through. You were kind of done with it, and that was part of your answer. So you just kind of set it on the side until you were ready to put it back into your final presentation. So if you're not sure if this is the correct answer, remember that you can check it. And this is how we will end the video. We're actually going to check this to make sure that we get back to the original problem. Now, I wouldn't recommend checking every single problem that you do just because that would take a very long time. However, checking the first few or so would allow you to make sure that you have the process down right. So I'm going to go ahead and I'm going to choose to multiply these two together first just because I think it'll be a little bit lighter. So AB times A will give you A squared times B, and AB times 1 gives you plus AB. And then we want to distribute it to the other binomial of 3A minus 2B. A squared B times 3A will give you 3A cubed B. A squared B times negative 2B gives you negative 2a squared b squared. AB times 3a gives you 3a squared b. And then AB times negative 2b gives you negative 2ab. So if you take a look, you might say, well, they don't look identical. The ordering, sorry, that should be squared. The ordering looks a little bit off. So, but do notice the following. I do have a 3a cubed b. That was the first term from above. I do have a 3a squared b. That was our second term. So it's over here now. I do have a negative 2a squared b squared. That was your third term. and then I do have a negative 2ab squared. That was your fourth term. I can just rewrite this. We have the commutative property that allows us to do this. So again, note here are your terms. Note that I am circling the sign in front of them, and I can just rewrite this. This is 3a cubed b plus 3a squared b minus 2a squared b squared minus 2ab squared. This is saying the same thing. So here are basically here are two different representations of the same problem, and notice that these two connect. They are identical. Okay. I know that one was a little bit more challenging. If you do have any questions on that one, please follow up with me.